Hello, this is Mrs. Boots, and this is our lesson on modeling logs. Now, when we did modeling, remember we could do some little tricks to try and figure out which model it was before we just started going through and guessing. So, for example, we would take the differences. So my x's are pretty incremental, right? I could subtract and get 1 all the way down, and that's beautiful. But if I look at the differences for my y's, they're not going to be constant. The linears, remember, if it's constant, first one's constant, it's a linear. Second one's constant, quadratic. Third one's cubic, so on and so forth. Then we learned that if the ratio was the same, then we had an exponential growth or decay. And that ratio, that rate, whether we're multiplying by 2 to get to the next number or dividing by 2, told me if it was a growth versus a decay. The logs are not so easy to figure out, and in fact, in the calculator, under the Stat menu, there's only one type of regression, and that is the natural log regression. You will not find a log base 10 or log base b. We only do the natural log, and that's okay. This is the format that the calculator gives us, and so when we plug in our table, the calculator is going to compute a and b. Now, realistically, guess what? We could, in theory, take points from our table and algebraically solve for a and b. We're just going to let the calculator do it for us, all right? So remember, my calculator's on, it's beautiful, okay? I'm going to go to the Stat button. I go to Edit, which it's on Edit first. I hit Enter, and I get to my table. So the trick is to make the table in the calculator match the table that's on your paper, right? So I'm going 1 through 6. My L1 is my X's, and my L2s are my Y's. So I'm plugging in each one of those numbers. Carry it out as many decimal places as you can. Otherwise, you round it off, it's not going to be as accurate, all right? So now that I've done that, I'm going to quit. So I go second mode and quit out of the function, and then I'm going to go back into my Stat. I'm going to go over to Calc and go down. Now we already said it was number 9, right? So I could have just pushed 9, but that's okay. It always gives us the menu list. We just hit Enter, Enter, Enter. It highlights Calculate. Yay! Enter. And now it gives us a big mess. Look at that. All right, but let's look at R. R and R squared, 0.999999. That's awesome. That means it's almost, practically 100%. So let's figure out what A and B are. Now I'm going to round them to the closest whole number because I know what the correct answers are, but also because I look at how those numbers are. So see, negative 8.9989. Okay, so even if I round it to 2 places after the decimal, 9's going to become a 10, that one's going to become a 10, next one. So A is negative 9, all right? B is what? 15. So my A is negative 9, my B is 15. So I have negative 9 plus 15 ln x. Easy enough. Now we have our model, okay? So we're asked the domain, the range, the asymptote. We may be asked to graph that model and compare it with our points. So we would graph our points, graph the model, and compare. Are they over top of one another? So let's go to y equals, and we're going to plug in negative 9 plus 15 ln x. Okay, super easy. Negative 9, 15 ln x. We hit our graph button, and it gives us this wonderful, pretty graph right here. That's awesome. So as I look at that graph, look at the domain and the range, right? So the domain is starting where? It's starting at 0 and going to infinity. It's not touching the 0. So 0 is where my asymptote is. We didn't move the function left or right, did we? Did we? Well, let's look at it. Most of the time, you see it in the form, you would see it as 15 ln x minus 9, okay? And so all the calculator does is they put that 9, that constant, up front. It confuses some folks. But remember, this is not a horizontal shift. This is a vertical shift. It's moving it up and down. This 9 did what? Moved it down 9. Well, what does the 15 do? Yeah, it stretched it, made it taller. So it's 15 units taller, 15 times taller, and moved 9 units down. How would I know if there was a horizontal? That's easy. I would have something inside parentheses with the x, and that something would move it to the right or to the left. Okay, we're not moving it right or left, so my domain can start at 0, go to infinity, and my asymptote is going to stay at 0 because I didn't move it left and right. Those two are zeros. 0 to infinity, x equals 0. The range is the easy one because for logs, your range always goes from negative infinity to positive infinity. It doesn't matter if we move it up, down, left, right, that part stays the same. Let's do the other 3 examples. Example 2. In example 2, we have another table of data. So we're going to start by putting it into stat. So I go to my stat menu, I hit enter for my edit, and then I enter again the x's in the L1 and the y's in the L2. Remember, we can type over the previous answers or the previous numbers that were there. We don't have to delete them first. We can just type over them since it's the same number of entries. Okay, once we're done with that, I'm going to quit second mode, go back into stat, over to calc, and we're going to go down to number 9. Hit enter to select, and then enter, 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 and calculate. All right, so what have we got there? We said A is 4.999. Okay, I'd say that's a 5, right? And B is negative 2.002. If I round that to 2 places after decimal, it's just negative 2. Notice the R squared and the R is still really, really close to 100%. So rounding's okay. So we have a 5 for A and a negative 2 for B. Let's put those in our equation. So my A value is 5, and my B value was negative 2. All right, so I have my A and my B. Now we had just said something very important about our domain. Did we shift this left and right? No, we didn't shift it left and right. If you wanted to, because this doormat bothers you, you can rewrite it as negative 2 ln x plus 5, right? All right, so now we can clearly see that 5 is a vertical shift. We're moving it up 5, which is why my very first entry is at the 5. Notice the entry matches the B value. I'm sorry, the A value. It matches that. Okay, that's kind of a self-check there that you didn't type anything wrong. And then we have a what? A reflection and a stretch with our natural log. So our domain did not move left and right. The function didn't move left and right. So we're going from 0 to infinity. The range is the easy part because the range goes from negative infinity to positive infinity. And the asymptote, because we didn't move it left or right, is just at 0. So the problem is that our wonderful stat function does great if I have stretches, compresses, reflections, and vertical shifts. It doesn't handle the horizontal shifts. It's kind of, I guess, a limitation on the program. They didn't think about it. So what we're going to do is we're going to look at an equation that has a horizontal shift. So in the next example, we give you the equation, right? What's the 3 doing? The 3 out front is a stretch. It's going to be 3 times as tall. What is the 21 on the inside doing? Correct. It's moving it left 21. Remember, we do the opposite. Are we shifting this function up and down? No. There's nothing outside. So there's no vertical shift whatsoever. Okay, it's just a horizontal. So if we drew a graph, just a little quick sketch, not too crazy, we would go over 21 to the left, right? 1, 2, 3, 4, 5, 6, 7, 8, 21 tick marks over. This is negative 21, all right? And our graph is going to come along the negative 21 and do something like that. Because it's a log function, It's not reflected. It's super tall because it's 3 times as tall, and it moved to the left 21. Easy enough. Okay, so let's look at the graph on the calculator. Just double check ourselves. Now, if my graph is set to 10 by 10, am I going to see negative 21? No, silly. Okay, so I go to Window, and notice it says X min is set at negative 10. I need negative 21, so I'm actually going to do negative 22. Okay, that gets me past the negative 21. Now I'm going to go back to my graph button. Oh, looky there. See? Yeah, we got it right. We went over to negative 21 and we graphed it. Good job. Okay, but we need some values for our table. So the table, they want us to start at 1. Okay, so I'm going to go to 1, and what is it? So I got a 4.03. Remember, you're rounding, so the 2, since there's a 7 that follows it, becomes a 3. Then I have what? 4.09. Then I have 4.14. For 4, I have 4.19. Then it's 4.24 and a 4.29. All right, so all of these numbers, they're all around 4. Well, that makes sense, though, because remember, it kind of flattens off, right? So I'm all the way over at negative 21. It's come over, it's flattened off. So it's increasing, but not as fast, not as quickly. Let's do our domain and range. What would our domain be? Yeah, it's going to start at the negative 21. Does that negative 21 get a parenthesis or a bracket? It has a parenthesis. Why? Because we have a little vertical asymptote in there that we did not touch at negative 21. The range is still the same. Negative infinity to positive infinity. Asymptote, we just identified. X equals negative 21. Easy, easy. Not a big deal. Let's look at example 4. Again, we're given a table and asked to find the graph. So if we're using the regression model on the calculator, we're going to have a natural log. So I go to my stat and I enter in, under edit, all my values, x's and y's. Make sure you enter them in correctly. All right, notice we only have 2 decimal places on this, so it may not be as accurate. Obviously, the teacher rounded it when she wrote it down. Wonder how that happened. Okay, so we go back to stat. We go over to calc. We're going down to our linear regression. We could do other regressions. Remember, don't pick linear. We're picking the natural log. They're right next to each other. Okay, there's a difference between ln and lin. We're going to calculate. A is 0.999. What do you think? So A is 1, B is 7. Notice my correlation was 99.9%, so I have 1 plus 7. I'm not surprised by the 1 because it's right there in my table. That's my check. Now, yeah, I could have just gone ahead and written it down because for this type of model, it works that way. It doesn't always work that way, and that's why I don't just write it down, okay? What's my domain? Well, we move it left or right? No, we didn't move it left or right, so it's going to start at 0 and go to infinity. My range, same as always, infinity to infinity. And where's that asymptote at? It's at 0. X equals 0. Remember it's x equals? Because it crosses the x-axis. It is a vertical line. This concludes the review of modeling overall, as well as how we do log models. Remember, there isn't a shortcut of differences or ratios with the log models. You have to check it. You have to run it in the calculator. Or you have to know that this particular scenario can be modeled by logs based on research that was done by other individuals. Have fun with the practice.